Hi students, good evening. Welcome to this video session. I remain Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session we shall we shall continue our discussion on integration by algebraic substitution. This video would be part 2. Please, but before you continue with this video, it is very important that you view part 1 first. In part 1, we introduced this concept, and we found some integrals, some standard integrals that are got by algebraic substitution. Please, I want to add a correction to part 1. I want to add a correction, and the only correction I want to add is for this number 2, just put lean absolute value of f of x for number 2 and number 3. Okay, number 2, this is lean absolute value of f of x plus c, and number 3, this is negative lean absolute value of f of x plus c. So these are just the 2 corrections I want to add to that. We derived these in part 1. Okay, please, the transcript of this video and more examples, because for you to understand this concept well, you need to solve numerous problems on that. You will get it at my website www.samuelchukwuemeka.com. You can also go to www.chukwuemekasamuel.com. Any of those 2 websites, you will get it there. When you go to this website, or the other website, you click on mathematics, click on calculus, and click on integral calculus, and I keep updating notes. By the grace of God, as time demands, I update notes. It's a lot to write and solve, but at least I'm solving already. I've put in something so you can look at those. When you begin to solve the problems, and the solved examples, you have the solved examples, and then you have the applications. The applications are the word problems. When you go to solve any problem, first of all, attempt it on your own. Begin with the solved examples. Those are the ones I'm focusing a lot more now. But just give me some time, as time demands, by the grace of God, I'll keep updating those. So, but when you're going to solve those problems, I did not specify what method you should use. And I did it on purpose. Some professors will just give you problems to solve, and they will not give you hints. Okay, and I don't blame them at all, because they want you to know what method to use. So you just solve it first, because it will be so many problems. I did not specify what method you use. No, what method for you to use to solve the question. So, because I want you to know what method to use. But after solving it, look at the show answer, and you will see I listed the method that I used, and I explained it very well. I think I did. Just let me know. But I try to explain it as to as simple as possible so that you will understand it. Also, for some applicable questions, we will check our work by finding the derivative. So we're not going to check in this video because it's going to take time. But if you go to my website and review the transcripts, you will see those for some applicable questions. So after finding the integral of the function, how do you know that it is correct? You find the derivative of the integral. If you find the derivative of that integral, it will give you back the function. If it does not give you back the function, then most likely it is incorrect. Okay, so that is one way to check. Another way you can check it is with the calculator on my website. You will see it on my website, Integral Calculus Calculator by Wolfram. Okay, now Wolfram didn't pay me. So Wolfram didn't pay me to talk about their software. Okay, but I hope they acknowledge me, right? Because I'm trying to say, hey, this is a good product. Now, some of the answers you use from Wolfram, some of them are not simplified. Okay, but don't panic if you don't get the same exact answer as their calculator. Don't panic. Okay, don't panic. It could still be correct, even though it doesn't look exactly like theirs. So Wolfram didn't pay me to talk about them. They did not. But it's something that, hey, if you are not really sure, okay, you can just type it in and check it. So you can check by, of course, the most accurate way to check is by finding the derivative of that integral. You find the derivative of that integral. If it gives you back the function, good. Okay? Then that means you're correct. Or you can use the calculator on my website. Alright, we are going to solve some questions tonight. We are going to solve it, and we are going to, of course, we are using algebraic substitution. We will continue from where we stopped, but we'll just, follow from part, this will now be part 2. Part 2. So, I'm going to call it question 1, but, go through part 1. We did some questions there. And I don't know the number we stopped in part 1. I didn't check. Okay, but at this part 2, we will continue from the question 1. Okay, and I will explain it so that you can understand it. I will. Question 1, we have find the integral of 21 e to negative 7 over x all over x squared dx. So remember in part 1 we said that for you to find an integral using algebraic substitution, what do you substitute? You have to do a substitution. Then you find the derivative. Okay, then you find the x. Then you now substitute it. It now gives you a simpler form. You find the integral of that simpler form and you substitute back. That is the way algebraic substitution works. We've got to follow those steps. If you follow the steps I explained in part 1, which I will still do here in part 2, trust me, you will understand it. Just follow those steps. Most textbooks that I've seen don't follow those steps, you know. And I'm not going to bash any of them or mention any name. No, that is none of my business. My business is for you to understand it, comprehend it. That is my business, for you to understand it. So you look at this now, you ask yourself, what do I substitute? You substitute so that when you find the derivative and you substitute back, something might cancel, okay? And it's not mandatory that something must cancel. It will just make it a simpler form for you to now find the integral. Because if you look at this now, of course, the first thing we need to do anyway is let's bring out 21. Okay, let's bring out 21. Let's always bring out the constant. You know, let's bring it out so it does not interfere with us. And then you look at this. It is not easy to just find the integral. It is not easy like this to find the integral. You know, so you now say, okay, if I substitute for x squared, okay, p to be x squared, the p dx will give me 2x. The x dp will give me 1 over 2x. The x will give me the p over 2x. If I substitute it for the x back in this main integral, it will not cancel. It's not going to simplify. It will even make things probably more confusing. Okay? Or it will make things, it's not going to help me because I will have the p and I will still have negative 7 over x. That's the problem. I'm going to still have negative 7 over x. So I will say, okay, let me substitute negative 7 over x. It might be better, okay? So, because if I substitute with this, it will give me, it's gonna still give me problem. Because I will still have x and I will have p. And then the p. And that's a snag, you know, it's just at a standstill, no. So we'll now say let p, the substitution, be negative 7 over x. So this means that p is negative 7x to negative 1. Okay? I believe by now you know this. You know the power rule of derivatives. So we find the p dx. The p dx is 7x to the negative 2. Okay, that is the p dx, which is the p dx is 7 over x squared. Okay, 7 over x squared. So the x dp, we find the x dp. Please, if you don't know what I just did now, then boy oh boy, you need to just stop and go to derivatives right away. You click on differential calculus. Okay? Yeah, you just need to move on. No, you gotta know differentiation before you come to integration. You have to know how to scatter before you know how to gather. You know, integrate. Let's integrate. So that is one thing I like about America. Integrate. Let's live together. Why are we fighting? Oh, why are we fighting? Integrate rather than differentiate. Okay? Don't come and differentiate. You don't know where you go. But I get those people together. Integrate. Okay, so the x dp is x squared over 7. So we see that the x is x squared dp over 7. So we need this, and we need this. Okay? We need that. So you will see now how it will cross out. You know, it will simplify so that it makes it easy for us. All right? So now, this means, okay, from here, from here, that's from here, so this means that integral, I have not forgotten 21, no, I will still get this, guy, 21, but for now, I don't need it, I don't need 21 right now, let it stay out. Okay, so this means that integral of e -7 over x squared dx will give us, we now make that substitution. This is e exponent p over x squared times our dx. Our dx is x squared dp over 7. X squared dp over 7. Okay? I will use the yellow chalk to cross out. So see now, this is simplified. So that is the essence of integration by algebraic substitution. You make some substitution so that you can find a simpler function to integrate. That is the whole thing. And you know, after integrating it, do not forget to substitute back. You have to substitute back. So this will now give us integral of e to the p dp over 7. So this is easier for us now. It's easier for us. So this is 1 over 7 integral of e dp dp. Okay? 1 over 7 integral of e dp dp. So this is 1 over 7 integral of e dp, of course, is e times e to the e raised to power p plus the arbitrary constant plus c. Okay, now we will not forget this guy, and you know, so let's go ahead. We now have 21 times 1 over 7 times e. Remember our p, they gave us in x. The function is in x, the x. Our answer must also have a function in x. So e to -7 over x plus c. So 7 into 7, 1, 7 into 21, 3. So the answer is 3e to -7 over x plus c. And that becomes your answer. That's it. That is it. And like I said, we are, you know, they gave it to us as a negative fractional exponent. So our answer, we give it back to them as negative fractional exponent. Whatever form, if they give it to you in radical, give the answer in radical, unless your professor says something different. But if the question has radical, your answer, let it also have radical, you know, as applicable. If they give it to you in fractional exponent, give it back to them in fractional exponent. Okay? Yeah. So that's the answer. Now, we would have checked this by finding the derivative. If finding the derivative of this to make sure we get this. However, because of time, we have more questions to solve. So because of time, just, you know, review it on my website. Okay? Now let's go to question 2. Question 2. Dos. Question 2. Dos. Uno, dos. Uno, dos. Question 2. Dos. Okay. Question 2. We have integral of 15 m square root of 4 minus m squared dm. Okay. Everything must not be x. No. Everything must not be x. Now. Okay? It must not be x. It could be any variable. Alright. We look at this here. 15 is just a problem. Let's bring that 15 out. We bring it out. 15 m times square root of 4 minus m squared, the m. So, we see here, what do we substitute? We see here already, of course. When you're doing substitution, don't try to put trouble on yourself. Don't try, what do I mean? Don't try to substitute such that when you find the derivative, it will still contain radical. Avoid using radicals when you substitute. Just look at the radicand. The radicand is the term inside the radical. The radicand is 4 minus m squared. Okay, so you could use substitute with n, but if you substitute with n, when you find the derivative, it gives you 1. So you will still be stuck. Okay, but when you substitute with 4 minus m squared, when you find the derivative, you're going to have negative 2m. So you can have something to cross out. You understand what I'm saying? Okay, and some people will say, hey, Mr. C, why don't I just use parts? Parts, you know, integration of products or integration by parts. And that's okay, okay? Some problems you can use integration by algebraic substitution, and you can also use integration by parts. However, you know, I have taught parts, integration by parts, I've taught it. And some students, you know, they just do Cal 1 and they don't do Cal 2. When you do Cal 2, then you do integration by parts. Cal 1, normally you don't do integration by parts. You do the power rule of integration, and you do integration by algebraic substitution. But you know, Cal 2, they now talk about integration by parts, integration by partial fractions. Okay, and I taught those first. I've taught those. So for the folks that are taking only Cal 1, I'm gonna spare you that parts, integration by parts. But if you still want to see how we could use that, then you know, when I put those solutions on my website, then I look, you know, any ones that I can do both ways, I will also show you. So whatever method you prefer, you use. Okay. I like choices. You know, I like choices myself. Yeah. So, but for this video, I just want you to understand integration by algebraic substitution. Yeah. But if you already know integration by parts and you want to use it, that's fine. You will still get the same answer anyway. Okay, so I'm going to substitute with 4 minus m squared. That's what is preferred. That's what will work in this case. So I will say let P be 4 minus m squared. The P, the m, we find the P, the m, and that is minus 2m. The m, the P. You see the steps? I explained these steps on my website. You've got to follow the steps so that you don't make mistakes. Okay? I mean, only God does not make mistakes anyway. Human beings, we make mistakes. But just for you to avoid this, how about for you to avoid mistakes? Okay? So the MDP is negative 1 over 2m. So this means that the m is negative the p over 2m. So I will need this and I will need this. I will need that. So 15, I will still get 15. I don't want to worry about it right now. This is my concern. So this right now would be integral of m times m square root of p. Okay? Times, this means m times. That's what it means. I mean, some people will say, why did you erase times? Okay, let me just put it. M times square root of p times the n. And the m is negative the p over 2n. Now I can cancel. See that? And let me bring out the constant. I don't like constants inside the integral. I don't, honestly. Let's not worry about the constants. So this will now be negative 1 over 2, bring it out, negative 1 over 2, square root of p dp. See that? Okay, power rule. So let's focus on, we will still need this. Of course, 15 times this. For now, I don't care about it right now. Okay? So integral of square root of p dp is integral of p to the 1/2 dp. Okay? Which gives us p 1/2 plus 1 all over 1/2 plus 1 plus c. You now put your integration constant. Okay? Arbitrary constant of integration. So this will now give us p half plus 1 is 3 over 2. 1.5, which is 3 over 2. Okay, this is 1 over 2 plus 2 over 2, all over 1 over 2 plus 2 over 2. So this is now p 3 over 2 divided by 3 over 2. That's what it means. Plus c. Okay, this is p raised to the power 3 over 2 divided by 3 over 2 plus c. Which will give us p, because interestingly, some people mess up in just simplifying. Can you imagine that? Like some students, they do it well and they just make mistake on the simplification. So if you're not timed, like I don't time my students during tests. Okay, if you're not timed, then just don't mess up in the simplification of fractions. Don't mess up on that. So you don't lose some points. So you do not lose some points. So this times 2 over 3. 2 over 3 plus c. Alright, now let me get everybody. Let me now get everybody. I want to get everybody. So 15 times negative 1 over 2 times p exponent 3 over 2 times 2 over 3 plus c. Okay, we can cross out. 2 cancels 2. 3 into 3 is 1. 3 into 15 is 5. So we now have negative 5p exponent 3 over 2 plus c. Okay, let me say something here, folks. They gave us radical. I mean, some professors, you know, they don't mind you writing this. And that's okay, they don't want that. I mean, you know, some professors, they just negative 4 minus m squared raised to power 3 over 2 plus c. Some professors don't mind this. Okay, they will still give you full points on that. Some do not mind. However, I want us to, because we did algebra. Okay, so let's simplify this to the very minimum, to the least. Let's simplify this to the least. Okay, simplification, surprisingly, simplifying to the least is a problem for some students. Surprisingly, like they get the concept, but it's just simplifying to the least answer. Okay, so now some professors will allow this, no problem. Okay. However, what Mr. C will teach you is, if they give it to you in radical in the question, give it back to them as radical in the answer. And some people will say, okay, Mr. C, why don't I just write this? Negative 5 square root of 4 minus m squared all cubed plus c. Okay? Now, some professors will also take this. Okay? However, this is not the simplest form now. Come on. It's not the simplest form. It's not. So, I want us to do it simplest form. Okay? And, you know, if whatever your professor wants, give it to him or her. Okay? Now, I'm going to come here because I don't like working with big radicals. So let me come back to this p 3 over 2, simplify it, then I now substitute. How about it? Let me do that and then I substitute. So this is what I'm going to do here. This is what I shall do. I'm going to come p exponent 3 over 2 is square root of p all cubed. So this actually means square root of p all squared times radical p. You know, that is what it means. I mean, root p times root p times root p. That is what it means. Root p times root p times root p. Radical p times radical p times radical p. Okay? So this gives you p. P times radical p. And that is p radical p. Okay? So now, the answer that, so this will now be p radical p. P radical p, you now substitute back. You make sure you substitute back. So this is 4 minus m squared radical 4 minus m squared. That is what it is. That is what it is. So now we can now finish up. We can finish up this. So this is now negative 5 times 4 minus m squared, then times 4 minus m squared plus c. Okay? And you can leave it like this. Actually, I like this. Not really. I I don't really like this because you can still simplify this. So this is negative 5, 2 squared minus m squared times square root of 4 minus m squared plus c. And then we use difference of two squares. Difference of two squares, and our final answer. Our final answer would be, can I write it here? I hope you don't get confused. Our final answer would be negative 5, 2 plus m times 2 minus m, then square root of 4 minus m squared plus c. That's our final answer. That's it. Okay? Alright, let's do question 3. Let's do question 3. Question 3. Tres. Uno, dos, tres. Question 3. Uno, dos, tres. Okay. Question 3, I have integral of k squared plus 3 over, and we are doing varieties, okay? K squared plus 3 over cube root of k cubed plus 9k. The k integrate with respect to k. Like I said, it must not be x. It must not be x. Okay, so we look at this here. Some people will say, hey, can I use the numerator? Okay, like I said, don't stress yourself by putting radical at all with substitution, no. But look for the radicand as applicable, okay? But with most questions, you visualize it first to know what to substitute. If we use the numerator, k squared plus 3, the k, p equal to k squared plus 3. And you know, I like using p. You know, some people ask, why do you like using p? I like being positive. I don't like being negative. I like being positive. Okay, so p equal to k squared plus 3. You find the p, the k is 2k. And you can't, you know, there's no way you can cancel, you know. But if we use k cubed plus 9k, the p, the k will be 3k squared plus 9. And you can factor by GCF and something will cancel. See that? So sometimes you have to just look, you have to look at it first to know what term to use as this substitution. Okay, so we now say let p be k cubed plus 9k. We find the p, the k. The p, the k is 3k squared plus 9. And we want to just see how we can, you know, just make sentence easier right away. Factor right away, okay? And this will give us factor by GCF 3k squared plus 3. So that we can cancel out later on. See that? Then we now find the k, the p. The k, the p is 1 over 3 times k squared plus 3. So our decay is dp over 3 times k squared plus 3. We shall use this. And we shall use this. So this implies integral k squared plus 3 all over cube root of p. Cube root of p times dk. Dk is dp over this. dp over 3 times k squared plus 3. Okay? Now I cross out. And I don't like constants, so let me bring out constants. Okay? So this is 1 over 3 integral of the p over cube root of p. Okay? So this will be, I will keep this for now. I'll leave it. I'll come back to it. This is now, 1 over cube root of p, dp. I'm just explaining step by step. And you can skip some of the steps, that's okay. Okay? So this is 1 over p raised to power 1 over 3 dp. Okay? From law of exponents. So this will give us now, give us integral of p raised to power negative 1 over 3 dp. So which is now from law of exponents. So this is p negative 1 over 3 plus 1 over negative 1 over 3 plus 1 plus c, which is p 1 minus 1 over 3 is 2 over 3. Okay, p raised to power 2 over 3 divided by 2 over 3. Okay, plus c. So this is p raised to power 2 over 3 times 3 over 2 plus c. So this will give us, I bring out that 1 over 3. Let me bring it. 1 over 3 times p raised to power 2 over 3 times 3 over 2 plus c. See that? I cancel. So I now have cube root of p all squared over 2 plus c. And cube root of p all squared is not gonna, we can't simplify it further than that. Okay? So we just substitute back. Now if it was p 3 over 2, then we can do that. We can simplify further. But this is now cube root of p all squared over 2. So we just substitute back. This will now be cube root of, because they gave it to us in radical. So give them back the answer, let radical be there. As applicable. Cube root of k cube plus 9k all squared over 2 plus c. Okay? And some people will say, hey, can I square this and put the cube root? If you want to, that's okay. Okay, but this is still simplified. That's okay. Alrighty? Okay, the next question will be question 4. Part true. Question 4. Question 4. Now, let me say this We can still simplify this further. Okay, we can simplify the radicand. We can simplify the radicand. Okay, so let's do it further. Let's simplify it to the least. So this will give us cube root of k is the GCF, factor by GCF. K squared plus 9. Okay? All squared over 2 plus c. Now, we don't have sum of two squares. No, we don't. So I think this is the list here. Okay? Yeah. That's the answer. Okay. Let's do question 4. Let's do question 4. Question 4. We are getting there. We will not solve all the questions. We will solve some. I don't want this video to be too long. We'll solve probably 4, 5, 6, 7. About 4 more questions. Okay? And then the rest, you just view it on my site. By the grace of God, as time demands, I will be adding more. Now, if you have any questions, now, not your homework assignment, not your homework assignment, but if you have anyone that is challenging, that you could not do, and that is challenging, okay, you can send it to contact me from my website. But if you're my student, of course, ask me from the school system. My students don't contact me from the website. Now, when you contact me, just be positive and just, you wait. You wait till I respond. But if you're positive, then if you're positive, I'll respond. Okay? Make sure you're positive. I don't like negativism. No. Mr. C does not like negativism. No, I don't. Okay. Number 4. Let's see this here. Integral of x over square root of x minus 4 dx. Okay, this is another trick. This kind of question is also another trick with algebraic substitution. To be honest with you, normally if I'm like in an exam mood and I'm timed, I might go with parts right away, integration by parts or integration of products. Some people will say, let me try this right away because they saw x. So they'll say, but that's square root of x, 1 over square root of x minus 4. It's also a hindrance. Okay, so some people will say the first thing some people will do is if they don't specify, hey, solve this by algebraic substitution, some people will just think, hey, I'm going to do this by integration of products. But to be honest with you, I think integration by algebraic substitution is faster to do with this. I mean, it's up to you though, it's up to you, whichever one you prefer. But we want to solve this by algebraic substitution. So here, here's the problem, because you might say the ones we've been doing, maybe you have something like x squared minus 4 as the radicand. So when you do derivative, you can get 2x. So you can cross out the x and make it easier. Okay, no, this is x minus 4. So it's just a little more, mathematics, they put tricks. I mean, we're not tricks. It's not tricks, I take it back. It's not tricks, but they just want to twist some stuff to shake you a little bit. Okay, so in this case, I would advise you to use substitution x minus 4 in the radicand rather than using just x. Okay, rather than using x, use x minus 4. So we say let p be x minus 4. We do the p dx is 1. Okay, so the x, the p is 1. So the x is equal to the p. No problem, we know. So we're going to use this. The x is equal to the p. I just want to use yellow chalk to circle it. Alright. So this implies x over square root of p times the p. And that is the problem. You say, okay, Mr. C, I'm still stuck. I'm stuck. I know. But I don't want you to be stuck. I want you to keep moving. Move. Okay, so you ask yourself, can I express x in terms of p? Because this x is a hindrance. This x is a problem. Can I express x in terms of p? Can I make x the subject of the formula? Okay, so from here, let p equal to x minus 4. This implies that x is equal to p plus 4. And that is what we're going to use. X equal to p plus 4. So that is what we are going to use. That is just a little trick there, or little work extra you need to do there. So this will be now integral of p plus 4 over square root of p dp. Okay? Let me maximize this space. So this will be integral of p over square root of p dp plus integral of 4 over square root of p dp. I hope you understood this step I did now. Okay, let me put this step in case you did not understand what I did now. Let me simplify. So this means integral of p over square root of p plus 4 over square root of p dp. Okay, you like this step now? So this will be integral of p over square root of p dp plus integral of 4 over square root of p dp. Alright. I'm going to do this step by step. Okay, let me do it step by step. Let's do it step by step. So integral of p over square root of p dp means integral of p over p exponent 1/2 dp, which is integral of p 1 minus 1/2, because this means p exponent 1. Right? So p 1 minus 1/2 dp, which is integral of p exponent 1/2 dp, which is p 1/2 plus 1 over 1/2 plus 1. Okay, I will not put plus c right now because the arbitrary constant comes at the end. So since I have two integrals, let me just do them, and at the final answer I put the arbitrary constant. So this gives us now This gives us equal to p exponent 3 over 2 divided by 3 over 2. Because 1/2 plus 1 is 3 over 2. So this means p exponent 3 over 2 times 2 over 3. Okay? Which is 2p exponent 3 over 2 over 3 times p, okay, exponent 3 over 2. Alright, please, let me go ahead and simplify this right away, please. Let me go ahead and simplify it. So, okay, p is, yeah, because this is square root, okay. So, p exponent 3 over 2 means square root of p all cubed. Okay, so that is square root of p all squared times square root of p. You see that? So this will be root p root p. So this is 2 over 3 p root p. I'll keep this first. I'll keep it. Let me first finish everything with p, then final answer I substitute back. Alright? So, 2 over 3 p with p. The next one, integral of 4 over root p dp will give us, I don't like the constants inside the integral. Okay, so bring it out. 4 integral of 1 over root p dp, which is, leave the 4. We will come back to 4. Okay? I'll circle it. We shall come back to it. So now, we have integral of 1 over p exponent 1/2 dp, which is integral of p exponent negative 1/2, law of exponents, dp, which is, let me write this integral well. So which is equal to p exponent negative 1/2 plus 1 all over negative 1/2 plus 1. Later we will put c, the arbitrary constant. We will put it later on. So this will be p exponent 1/2 divided by 1/2. Okay? Because negative 1/2 plus 1 is 1/2. Alright, so this will give us now equal to p exponent 1/2 times 2 over 1. Okay, now, which will now give us 4. Let's bring out the 4. 4 times square root of p times 2. So this is 8 square root of p. 8 square root of p, 8 root p. Right? Okay, now let's join everything together and see, simplify to the list. Oops, I just missed it. Okay, let's finish this up first. Let's simplify to the list. Simplify to the list. Simplifica. Alright, so this will be equal to 2p root p over 3 plus 8 root p plus c. Right? And what is, can we factor something out? We can factor something, right? So this will be 2 root p can come out, and we have p over 3 plus 4, right? Plus c. right? Okay, 2p root p over 3 plus 8 root p. So we factor that by GCF. So this will now be 2 root p, p over, this is 4 over 1. So this is actually p over 3 plus 12 over 3 plus c. Okay? So this will now give us 2 root p let's still use bracket, p plus 12 over 3 plus c. So now let's finish it up. 2 square root of, our p was x minus 4, because you have to substitute back. 2 times square root of x minus 4, okay, times x minus 4 plus 12 over 3 plus c. And our final answer will be 2 square root of x minus 4 times x plus 8 over 3 plus c. And that's it. Simplifying to the list. That's it. Okay? I mean, if you want to expand, that's okay, but this is simplest. Factored form, in the factored form. In the factored form. Okay? Alright. Let's do question 5. Let's do question 5. Question 5. Cinco. Question 5. Cinco. Cinco, 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 cinco. Cinco. Question 5. Cinco. Oh, I need to raise this one. Now, this was the assignment I gave in part 1. In part 1, that was the expression you saw there was the assignment I gave in part 1. So I hope you do that assignment and check your answer on my website. Okay, question 5. Let's see whether we can do some trig. Integral of cos 1 over x all over x squared sine 1 over x dx. Okay? You know, with trig, with exponential, with logarithm, you can do several of them by algebraic substitution. And you know, because of time, I would have loved us to do more trig, but just check them on my website. I just want you to have an idea, to understand the concept, what you need to substitute, and the way it works. Okay, that's what I want you to understand. So that way you can, you know, by the time you solve more problems, you will grasp it. Okay, I know some of you have already grasped it by now, right? So if you have grasped it, if you have understood it already, come on, why don't you give me the credit? Come on, why don't you give me the credit? Because you didn't know it, and I taught it, and you understood it, right? So you give me the credit, and I give the credit back to God. You give me the credit, and I give the credit back to Jesus Christ. You give me the credit, and I give the credit back to Jesus Christ. That is what I do. Okay, so here, what do we substitute? What do you think? You know, what do you think? As you can see here, you have cos 1 over x, you have sine 1 over x. Oh, And then if you use 1 over x, when you find the derivative, you're going to get negative 1 over x squared. So something can cross out, you know. But if you use x squared, you're going to get 2x, and then you're going to get 2x, and then you will still be stuck with x and p, because that's still 1 over x. Yeah. So you just look at this now. You should know by now, hey, I'm going to use p equal to 1 over x as the substitution. Don't even think about using x squared now. Okay, so we say let p be 1 over x. Okay, this means that p is x to the negative 1. So the p dx will give us negative x exponent negative 2. Okay, so the p dx is negative 1 over x squared. Negative 1 over x squared. You see that? So dx to p dx to p dx to p would be negative x squared. That means that the x is negative x squared dp. So this is what I need here. And I need this here. Okay? So this implies that this is integral of cos p over x squared sine p times negative x squared dp. See that? Okay, I cross out, bam, bam. Right? So now I don't like that negative 1. I bring it out. Okay, negative, I bring it out, which is negative 1. Cos p over sine p dp. Now this is, remember the standard integral. You know, remember the standard integral that we did this in part 1. We did integral of this type. Is a standard integral. If you have f prime of x over f of x dx. We did this in part 1. Okay. So let's say that your professor did not give you standard integrals. Okay. We did this in part 1. And this is a lean. This will give us lean f of x, absolute value of f of x plus c. This is a standard integral. Some textbooks will write table of integration or integration tables. Okay. I call it standard integrals, list of standard integrals. It's the same thing. Some professors will not give it to you. Okay. I have that list on my website, and I'm still adding more because it's allowed. Now, but let's say your professor didn't give it to you. Okay? You will now have to do another substitution here to solve it. Another one. So, what variable do I use now? I'm going to say, I will leave this negative 1. I'll keep it. Okay? I'll keep it. But let's say they didn't give you this. Okay. So you're now here. We'll now say, okay, let, what should I use now? Let E, should I use, okay, let me use E. E be sine P. The E, the P is cos P. the P, the E, I am doing integration again. You know, just like in the videos we did on integration by parts. There are some questions we did 2 parts. So yes, sometimes you have to do integration twice. You have to do integration by algebraic substitution twice, like in this example. Okay? So the E, the P is cos P. The P, the E is 1 over cos P. So this implies that the P is the E over cos P. Right? So I need this, and I need this. So this means here, okay, this means here, I still have my negative. Let me keep it, okay? I still have the negative, not my own, no, not my negative, no. I still have this negative, okay? I keep it. So this means integral of cos P over E times the P is VE over cos P. Right? Okay. So this will be integral of the E over E. And that gives us ln absolute value of E plus C. And that gives us ln absolute value of E is sine P. Sine P. Okay, plus C. Okay, now we are going to get back this negative now. We will now get back our negative. So this is now negative ln absolute value of sine P plus C. But remember, they gave it to us in X. We have to put back in X. So the final answer would be, the final answer will now be equal to negative ln absolute value of sine 1 over X plus C. That's the answer. Okay. All right. Let's do 2 more problems and then we call it a night. At least we'll do 2 more problems. At least we are doing varieties. Varieties. So you get exposed to several varieties. We shall do 2 more varieties and we can call it a night. Okay. All right. Question 6. Question 6 says, Question 6. We have integral 4e exponent x over 4 plus 4e exponent negative x over 4 all over e exponent x over 4 minus e negative x over 4. dx. Okay. Let me go ahead and erase this. Excuse me. So, you look at this question and what do you think? What comes to your mind? What do you think you should do? What do you think you should substitute? I mean, some people will say, okay, since you don't like 4, maybe the numerator, if you can factor out 4. Or some people will say, hey, let's use 4, let's still use it like that and see what it will be. It just depends on, what you're gonna use. But if you kind of look at it, well, if you differentiate if you remove 4, okay, if you say, okay, because I don't like, to be honest, I don't like the constants inside I try to, simplify them out. So that's for me the way I would do it. But some people will still just go ahead and do it, okay? But let's make it easier. Let's get our constants as much as we can. So if we do that, this will be 4 if you factor by GCF, and this is e exponent x over 4 plus e exponent negative x over 4 all over e exponent x over 4 minus e exponent negative x over 4 dx. So I go ahead and bring that 4, integral of e exponent x over 4 plus e exponent negative x over 4 all over e exponent x over 4 minus e exponent negative x over 4 dx. So we will still use this 4, but for now I don't need it. So now you ask yourself, the numerator and the denominator are similar. The only thing is the plus on the numerator and and the minus in the denominator. Some people will just say, let me try numerator first and see if it works. And if it does not work, then let me try the denominator. If you're working with time, to be honest, I don't want you to do that. Okay? So ask yourself this question. If I differentiate who should I differentiate? And when I differentiate it, it will give me the other, something will cancel out. Okay. If we differentiate the numerator, just on a quick view, we have 1 over 4 e exponent x over 4 minus 1 over 4 ex exponent 1 over 4 minus 1 over 4 e exponent negative 1 over exponent negative x over 4. But if we take the other one, the x, the p, okay, will it cancel out? So let me just show you what I mean. I know what to use. Trust me, I know what to use so that it will cancel out. But let me show you let me kind of show you what I mean first. Let's start with the numerator and see, let's start with the numerator and see. So if we say let p be e exponent x over 4 plus e exponent negative x over 4. Okay, so I believe you know how to find the derivative of this. Okay, the p dx You know how to do that, right? I mean chain rule. We're going to use chain rule. Chain rule. So if I have y to the e x over 4, so let u, like I said, let p be x over 4. So this means that y is e to the p. So the p dx is 1 over 4. Okay? And then the y dp is e to the p. So this means that, this implies that the y dx is the p dx times the y dp. The p dx times the y dp. This is chain rule. Okay? View my videos on chain rule. I've done it. Videos on chain rule. So this is the y dx will be 1 over 4 e to the p, which is 1 over 4 e to the x over 4. That is what it will give us. Okay? And of course, with this one, we have negative x over 4, but we find the derivative is negative 1 over 4. So this is giving us here 1 over 4 e x over 4 plus minus, because this is plus minus, okay, minus 1 over 4 e to the negative x over 4. That is what it will give us. Right? That is what it will give us. So if we simplify that, this will give us here 1 over 4. If we simplify it, e to the x over 4 minus e to the negative x over 4. So this is actually saying e to the x over 4 minus e to the negative x over 4 all over 4. That is what it is. Now, but we have to find the x dp. So the x dp will be 4 over e to the x over 4 minus e to the negative x over 4. Then we now find the x. Then we find the x. So our dx would be 4 dp over e to the x over 4 minus e to the negative x over 4. Okay, see what I'm saying, folks. See what I'm saying. If you put this dx here, if you put it here, will it cancel? If you put this right here, look, if you put this here, from here, forget about that 4 for now, okay? If you put this right now, this will be p over e to the x over 4 minus e to the negative x over 4 times our dx is 4 dp over e to the x over 4 minus e to the negative x over 4. You see the problem? We are still stuck on that. It didn't cancel out. That is the problem. It did not cancel out. So substituting the numerator will not work. It's not going to work. You see that? It will not work. Because this didn't cancel out. We are still stuck with p and with x. With respect to p. We are integrating this with respect to p. We are integrating x. Something, exponential function of x, with respect to p. Come on. So it won't work. So you see, sometimes you might just need, with time, sometimes you might ask me, okay, Mr. C, how do I know which one exactly? So I don't have to do this fast and see, hey, it didn't work, then let me now substitute the other one. Okay, you will know it. You will know it. It's just solve more. When you solve more problems, you will know it. You will. Okay. By the time you solve more problems, when you look at the derivative, you do the p dx, you do the x dp, Then you find the x. When you see it and you see nothing cancels, when you expect something to cancel, at least in this case, we expect something to cancel. I mean, with the way the question was set up, something has got to cancel. Okay. Now it didn't cancel. Then you know, hey, I didn't do the substitution right. So you try the other one. Okay, so we are going to do the denominator. So can we do it like, let's not erase everything. I will just do minus here. I will do minus. That is the denominator. Minus. So this will give us minus minus. This will give us minus minus. Okay? See, do you understand what I'm saying? Like this minus is this minus. Okay, we are now substituting the denominator. So minus minus gives us plus. So this is plus, and this is plus. That is plus. So this will give us plus, and this is now plus. The x. Now we can now substitute. So if we substitute from here, the 4 is still there, okay? From there, if we substitute, this becomes, or let me write it again, e exponent x over 4 plus e exponent negative x over 4 all over e exponent x over 4 minus e exponent negative x over 4. The x will now give us integral of e exponent x over 4 plus e exponent negative x over 4 all over p times 4dp over e exponent x over 4 plus e exponent negative x over 4. See that? Now we cancel. Bam, bam. Okay? So now we have, folks, can we now get that 4? Let's get that, well, let's bring out this 4. We now have 4. First of all, let's bring out this 4. 4 dp over p. Okay? Which is 4 ln absolute value of p plus c. Right? Which is, let's now bring that 4. 4 times 4 times ln absolute value of our p is e exponent x over 4 minus e exponent negative x over 4. Absolute value plus c. So our final answer will be 4 times 4 is 16 ln absolute value of e exponent x over 4 minus e exponential. This e means exponential, I hope you know. Because when I'm saying e, some people will think it's the variable e. No, it's exponential function, okay? Exponential exponential negative x over 4 plus c. This is the answer. Yeah, because when I'm saying e, some people will think it's variable. The e is not the variable, no. The x is the variable. The e is the exponential function. Okay. Yeah. All right. All right. Let's do one more question, and then we can call it a night. Okay. Let's do one more question, and we call it a night. Okay. Because I'm saying e. That is the exponential, please. It's not a variable. Okay. Let's do question 7, last but not the least. 7. Question 7, last but not the least, Seattle. Last but not the least, question 7. Okay, we have another one, integral of square root of 2 plus square root of x dx. So, you know, mathematics, they twist stuff. They twist stuff a lot in mathematics. Okay, folks, how do we go about this? What do you think we should substitute? Now, I know some people will say, okay, Mr. C, you've been telling us not to substitute with radical. You said use the radicand. And now you want to use 2 plus square root of x as a substitution. Why? Why don't you substitute with x? Okay, folks, we have two radicals here. So I know I said if you have a radical, you should just use the radicand. But I did not say when you have two radicals. I didn't say that. I said when you have a radical, use the radicand. But what happens when you have two radicals, like you have here? If you use only the radicand, and of course the radicand in the bigger one is 2 plus square root of x, I know. So it's still correct. Use the radicand there. Rather than using only x. Because if you use x, the p dx is 1, the x dp is 1, the x is equal to the p, you will still come back to the same issue. Seriously. So why don't you try, let's use the radicand inside the big radical. Okay, let's use that. Because here you have two radicals. But just use the radicand inside the big radical. Okay, when you have this. So we say let p be 2 plus square root of x. The p dx will be square root of x. I know by now, okay, by now you should know that square root of x, the derivative is 1 over 2 root x. By now you should know this, okay? But let me explain, let me still do it, because at least this will refresh your knowledge of integration, but knowledge of differentiation. But when you've done derivatives, so there are some that you should know by now, okay? Derivative of square root of x is 1 over 2 root x right away. But look at it anyway. Y square root of x means y equal to x to the half. So dy dx, y prime, is 1 over 2 times x, 1 over 2 minus 1. Okay? Which is 1 over 2 times x exponent negative half, which is 1 over 2 times 1 over x exponent half, which is 1 over 2 times 1 over root x, which is 1 over 2 root x. That's the y prime. Okay? So, the x dp is 2 root x over 1. So this means that the x is 2 root x dp. So we need this. And of course you will say that we need this, but let's see here. This now implies, integral of, you will say, okay, Mr. C, circle this first. Okay, let me circle it, no problem. So this is square root of p times 2 root x dp. So we are still having issues. We are still having issues because we have, with respect, we want to integrate with respect to p, and we are still having x. Huh? We can integrate people who will mess us up, who will kill people. We don't want to integrate people who kill people. No. No. So, people who kill people will have to repent to be integrated into the society. Into the society. So, we are trying to integrate x with respect to p. Is a problem. So, what do we do? Now, can we remove the 2 first? Because honestly, I don't like seeing constants. So this first, let me remove it first. 2 integral of square root of p times square root of x dp. When you come here, see what you can do here. Remember we did a question like this earlier on. How do we now, because we can't integrate x with respect to p, no. So we now have to substitute here back. Root x will give us p minus 2. See that? So from here, we have that. This implies that root x is p minus 2. And that is here. That is here. See that? P minus 2. So, I still, let me circle this 2. I don't want to mess with it now. Okay? So now this will now be integral of root p times p minus 2 dp. See that? So this gives us integral. We can go ahead and expand it. So we have integral p root p minus 2 root p dp. Right? So this will be integral of p root p dp minus integral of 2 root p dp. Okay? So let's start with this guy. Let's do this step by step. Let's start with this guy. P root p dp is integral of p times p, this is p exponent 1 times p exponent 1/2 dp. So this gives us integral of p 1 plus 1/2. 1 plus 1/2 dp, which is integral of p exponent 3 over 2 dp. 1 plus 1/2 is 1 1/2, which is 3 over 2. So this will give us p exponent 3 over 2 all over 3 over 2 plus 1 all over 3 over 2 plus 1. Okay? Let me not put plus c now until I'm done. Okay? So let's not put plus c. So this gives us now, this gives us p 3 over 2 plus 2 over 2 is 5 over 2. 1 is 2 over 2. Okay, so p exponent 5 over 2 divided by 5 over 2. So this gives us p exponent 5 over 2 times 2 over 5. Okay, can I simplify this p exponent 5 over 2? Can I simplify it first? Okay, so p exponent 5 over 2 is square root of p exponent 5. And that is equal to square root of p all 4 times square root of p. Now square root of p raised to power 4 is p squared. Okay, because this is actually square root of p is p raised to power half times 4 times root p. Okay, that is what it means. So this is your exponents, laws of exponents. Okay, look at my videos and notes. Exponents-logarithms.axpot.com. Okay, I explained it well. I explained it very well there. So 1/2 times, so this is p squared root p. Okay, now times 2 over 5 now, times 2 over 5. So now this gives us now, 2p squared root p over 5. Let's keep this. Let us keep it. 2p squared root p divided by 5. And the next one is 2 square root of p. Integral of, and this is, we have minus here, so let's not forget. So integral of 2 square root of p dp. Okay, let's remove the 2. So this is 2 square root of p dp. I will still get back this 2. Okay? And we also have that 2 right there. We also have the 2 there. Alright, so this will give us integral of p exponent 1/2 dp, which is p 1/2 plus 1 all over 1/2 plus 1. I shall not put plus c right now. No. Let's finish it first. Okay? So this gives us now, this gives us p exponent 3 over 2 divided by 3 over 2. So this will give us p exponent 3 over 2 times 2 over 3. Let us simplify p exponent 3 over 2. So p exponent 3 over 2 means square root of p all cubed, which is square root of p all squared times square root of p, which is p root p, p root p, p root p. So this will now give us times 2 over 3, okay? So p root p times 2 over 3 gives us now 2p root p over 3. So we need this here. Okay. And we still have that too. So what we are going to do now, folks, and this is, we have the minus here. Okay, so this is what we are going to do. We need to simplify this to the least. So, can we come here? Can we come here? Come here. Let's come here. So this is, let us not worry about C until we are done. Okay, we'll put C when we have substituted back in X for B for the X. Okay, so let's not worry about the arbitrary constant till the last answer. Just when you're solving problems, make it easy. Make things easy for you. Don't stress yourself too much. You know, this country is stressful already. So don't come and add more to your stress. Make things easy. Do it in bits and pieces. Do it in bits and pieces fast. Okay? So don't come and stress yourself more. You know? You already have stress already. Paying bills, learning math that probably you don't like, Okay. But you should, hey, come on now. You should like math. For you to, honestly, for you to learn integration should be that you eat math, that is, you like math. Although some people are in calculus, Cal 1, and some doing business calculus. So maybe they will, I don't know. But anyway, let's continue, okay? Let's continue. That's why I like to smile and make my videos, you know, so you can laugh, so you don't get stressed out. You don't stress out. Okay, so make it easy for you. Don't worry about the C, leave it. And don't forget about this too. Okay? Just do it first, then before you now add those stuff. Alright, so now we now have, this is 2p squared. And don't worry about, simplify everything first before you now substitute. Okay? So we have 2p squared root p over 5 minus 2p root p over 3. Okay. So we can simplify. This is factor by GCF. We have 2p root p, right? 2p root p. We have p over 5 minus 1 over 3. Minus 1 over 3. Right? Okay, let's simplify that. So we have 2p root p. We have a p over, well, let's now over 15, 3p over 15 minus 5 over 15. See that? Okay? Yeah, because over 15 over 15, 5 into 15, 3p minus 3 into 15, 5 times 1, 5. This is fractions, okay? So this will now give us 2p root p times 3p minus 5 over 15. Right? Okay, let's get back that 2. You see that 2? We still have that 2. So let's put back that 2. So this will give us 2 times 2p root p times 3p minus 5 over 15. So we have 4p root p times 3p minus 5 over 15. Okay, let us now substitute. Let's substitute back. Let us substitute back and see what we have. We have 4 times 2 plus root x, okay, times square root of 2 plus root x times 3 times 2 plus root x minus 5 over 15. Right? Okay? Now, can we do this step by step? Can we do this step by step, please? This is factored already. If it is in a factored form, please don't go and start expanding unless your professor wants it. I like mine in factored form. Simplest form is the factored form, honestly. Okay? And that is why we had to take care of, you know, everything before we now substituted. So this is what we need to simplify, and then we'll be done. So this here, 3 times 2 plus root x minus 5 over 15. will give us 6 plus 3 root x minus 5 over 15. Right? Right? So which is now 1 plus 3 root x over 15. So our final answer would be, we will write it twice. We'll do that and we'll do it again. 4 times 2 plus root x times square root of 2 plus root x times 1 plus 3 root x over 15. Okay, so the final answer, to make it easier, will be 4 over 15 times 2 plus root x times 1 plus 3 root x times square root of 2 plus root x. That is it. I mean, some people might say, Mr. C, expand this. 2 plus 6 root x plus root x plus 2 plus 7 root x plus 3x. I mean, I like mine in factored form. That's what I like. I mean, I don't know what your professor might want, but that is what I like. Okay? Okay. If you have any questions, please ask me. We will stop here for tonight. So we don't teach till. But you know, God gave me enough energy. I can teach for many hours. I can still be teaching. No, it's my joy. It's fun for me. Okay, but we will stop here for tonight. I hope that you have grasped, learned, and understood the concept of integration by algebraic substitution. If you have any questions, please feel free to ask me. Okay? Remember, if you're my student, please don't contact me from my website. Okay? Trust me, I don't like complaints. So, just contact me from the school system. Okay, thank you so much for listening, and you have a great day. bye.